Okay, so this is problem set 82, evaluating functions, and then a focus on recognizing domain and range. So we have done this before. We have evaluated functions, and if you look at this first example here, you've got a function which is f of x equals x squared plus x plus 1, and we're asked to find f of a squared. Now we've been asked to find f of other values, like f of 2, f of 3, but this might be the first time that we've been asked to find the function with a variable, or the function of a variable. But it works exactly the same way. We're going to take that a squared, and we're simply going to substitute it in for x within our existing function. So I'm just putting an a squared wherever there was an x, like so. And then all I have to do is evaluate it, and by it I mean the expression on the right, to figure out what f of a squared would be. So I'm going to go ahead and do f of a squared. I'm going to use my power of products rule, which would mean that we'd multiply these exponents together to get a to the 4th power plus a to the 2nd plus 1. And that's all we can do. So this would be what f of a squared would be. Let's take a look at a slightly more complicated example, but really not that much. This time we have f of x equals x squared plus 1, and we're asked to find f of x plus 2. So once again, we're going to take that x plus 2, and we are going to substitute it in for x. So f of x plus 2 is equal to, well, we got to make sure it's in parentheses when we plug it in, x plus 2 all squared plus 1. Now we are going to simplify this or expand it. Remember that x plus 2 squared is the same as x plus 2 times x plus 2. Don't forget the plus 1. We can use our little, little square thing that people like to use here with the x and the 2. Or you can use the FOIL method, whichever makes more sense to you. So we end up with, it's looking like x squared plus 4x plus 4 plus 1, which would get us 5. And so f of x plus 2 is x squared plus 4x plus 5. All right, now we're going to change the focus to domain and range. A domain is really just a way of saying what are the possible x values for this function. So I'm just going to put kind of in the brackets here the possible x values, the function, and then the range is really the resulting y values based on the possible x values. So this is kind of what we're looking for when we're looking at these functions here. Possible x values and the possible resulting y values, figuring out what you've got for your given domain. So let's look at this function here. We have f of x equals 2x. And remember that f of x is kind of like a replacement for y. You can think of it as being the y value. You can switch those back and forth. So if I think about this one, I think, okay, well, what possible domains can I get from f of x equals 2x? And the reality is that there really is no limit to what you can get for the domain, right? I can plug any real value in for x and get a y. So I would say that actually all real numbers will work for x. I can plug anything in here, and maybe this seems a little too obvious, and maybe it'll become more clear why this isn't always the case with a few other examples. But for this one, any real value will work for x. And as we take any real value and multiply it by 2, the resulting range actually kind of shows us that we can actually have all reals for the range as well, because if we plug in the resulting range has no limits because the domain has no limits. Now, let's take a look at this example here, which might be a little bit more complicated here. So what we have is we have f of x is equal to 3. Now, if you can imagine, this is kind of the same as saying y equals 3. And a y equals 3 graph would really be a horizontal line that goes through the y-axis at 3. So if you think about it, the domain and range does actually have some limits here. The domain are the x values. Well, the x values on a horizontal line that is parallel to the x-axis could really be anything because it goes infinitely forward and infinitely back. However, the range does have some limits, right? What is the range going to be? Well, it's not going to be all reals. It's always going to be 3. And again, if you think about how the graph would look for that, that should make some sense. The y is always going to be equal to 3 on a function that looks like this. So we have a couple more that we're going to look at domain and range of. There's an example here of a graph that I'm going to sketch out. Could be asked to find the domain and range of a graph. Okay. So here's a graph, and you might be asked to find the domain and range of some funky graphs that look like this. So we just have to ask ourselves, well, what can the x be? And in this case, the domain, well, x is going to be part of a set of all real numbers, right? But the thing about it is that it does have some limits. It's not going to be all real numbers. It's going to be a set of all real numbers. And it's looking like it's got to be greater than -2, because that's where this line is. And it doesn't include -2 because we have an open circle there. And I'll actually kind of demo that here, right? Open circle, -2. And the x can actually go all the way up to what? Well, it looks like it can go up to 4, but less than or equal to 4, including 4, right? So that's how we would write that. Essentially, x has to be greater than -2 and less than or equal to 4, and it can be any of the reals in between those values. What about the range? Well, let's talk about the range. The range, y2 can be part of a subset of reals, and within those subset of reals there are limits. It looks like our lower limit is going to be 0 because this point here looks like our lowest point, and that's at y equals 0. And our highest value, it looks like, is going to be at 3, if we kind of follow this dotted line here. So it's got to be between that dotted line and the line right down here, which the way that we would write that out would be that y is going to be greater than 0 and less than or equal to, I should actually say greater than or equal to 0, and less than or equal to 4, like so. All right, we go kind of back into the function world, off the graphs. This one we have f of x equals the root 5 minus x. And if we're looking for the domain of this function, well, the domain would be, this one only asks for domain, is going to be a set of real numbers. But the thing is that x has got to be less than or equal to 5. And the reason that x has to be less than or equal to 5 is that if it is more than 5, we're actually going to have a negative value under the square root. So I can kind of demonstrate that, right? If we did f of x is 6, for example, right? then what that would look like is the square root of 5 minus 6, and then we'd end up with the square root of negative 1. And we know that we can't find the square root of negative 1, so we can't go beyond 5. We could be at 5 because we can find the square root of 0, but we cannot be greater than 5 because then we're going to have to deal with a negative root. All right, what about this one? Another domain question. The domain of g of x is 1 over x. Well, we'll write our little domain notation. Once again, x is going to be a part of a subset of real numbers. And the only constriction here is that we can't divide by 0, right? Because 1 divided by 0 is mathematically impossible. So the way that we would write that is that x cannot equal 0. So give these a shot, evaluating functions and finding the domain and range of functions.